Welcome back. This is part 27 of my ELM test prep series. I'm James S. And this series is about helping you pass your ELM PAT test, which is an elementary level math proficiency acceptance test. This is how you get into your university, and it determines whether you take some remedial courses or whether you move on to your regular math courses. It also determines whether or not you spend a summer taking these remedial courses, which will cost you several $1,000s and lots of time. So I recommend prepare. Do not take this test lightly, even if you are a fairly good math student. If you've been away from your math for a while, it's likely that you'll forget things, and that's what we're after here is a quick reminder. We're also looking to give you the quickest approach to doing this test, taking the test, and getting the right answer. So, let's talk about exponents. What is an exponent? Well, if I were to just write down the number 5, it doesn't look like it has an exponent, but it does. There's a 1 up here. And since I know that to be true, I don't write it down. Any number has a 1. If it's anything other than a 1, I will tell you about it. It also has a plus out here. And sometimes you could think of there being a coefficient out here. I'll just put that in parentheses. 1 times that value is obviously just 5. So quite often we forget about the fact that there is a coefficient of 1 out there. When we start working with exponents here a little more, you'll see why that 1 might be helpful to know about. Anyway, so what does it mean if I have 5 squared or 5 to the 2? Well, that means I really have 2 5s multiplied times each other, and of course that is equal to 25, which is nothing real complicated. 5 times 5 is 25. Well, let's look again. Let's try something else. What if I have 5 to the 3? And I'm going to then say that, well, I have 3 5s times each other, and so the 5 to the 3 would equal 125. Well, that's pretty easy. Every time I go up a number here, I'd add another 5 out here. Straightforward, doesn't seem real complicated, and it's not at that point. So let's look at a letter. Well, I've got the letter A here. Well, I'm not good at A, so let's do a B. And there's B, and there's nothing written on it, so it's a plus B, and it has a 1 for an exponent, and we also have this coefficient of 1 out there that we don't want to forget about. So we have a plus 1B to the 1. Well, we don't write that, and we don't write that, because we know it's there. So we just write a B. Let's say we have B squared. Well, that means I have B times B. I don't know what the value of B is, but I know I have 2 of them multiplied times each other. Okay, that's fine. Let's also talk about how does a Let's talk about the length of reach of an exponent. The exponent can only reach as far as the very first thing it comes into. If you thought of a big table and you're sitting over here, your reach is only to that table. You cannot reach across this table. It's too big for you. Anything on this side of the table is not available to you. So if we think of the b as a table here and u being the 2, you cannot reach across the table to this negative out there. A lot of students would tend to say, oh, well, this is equal to b squared. Or if I gave you a number here and I said, well, that's 3, you would say, well, that's equal to plus 9. Well, no, it isn't. It's equal to minus 9. That's because this negative is beyond the reach of this exponent. It can only reach what it's attached to. The other thing on the other side of the table is not available. If you want to include that negative, you're going to need a parenthesis that goes around it. Now the 2 affects everything in the parentheses. So it would then affect this, and I would then get a plus 9. So be careful of negatives and exponents. Unless there's a parenthesis, the exponent has no effect on the sign of the coefficient out front. All right, so what if I have b to the minus 2? Well, I know b to the 2 would be b times b, but I've got minus 2 there. How do I represent minus 2 in terms of the number of b's? Well, this is a very special case of the exponent. It's a negative exponent, and it essentially says it's on the wrong floor. If I think of every number as being divisible by 1, I could say that there are 2 floors to every number. So let's say I want to make this a 0 here. I would add 2 b's. So I don't have any down here, so I'm going to have to add 2 b's times that 1, right? Okay. So now minus 2 and plus 2 is b to the 0, and b to the 0 equals 1. Well, now I've got b to the 1 on top, but I have b squared on the bottom. And so now I've gotten rid of my negative exponent. And certainly one way to do that is the mathematical operation here. Quite often, we just realize that b to the minus 2 is on the wrong floor, and I invert this and I say, well, that's 1 over b squared, and I then have a positive exponent. So this typically, the negative up here inverses the value. Instead of b over 1, it's 1 over b. Now, this does not have anything at all to do with the sign out front. This negative has nothing to do with whether or not this is a plus or minus out here. This negative is only determining the inverse. It just says it's on the wrong floor and I need to invert it. All right, that's negative exponents in a nutshell. So let's talk about fractional exponents. X to the 1/2. Well, I know what x to the 1 is, but what is x to the 1/2? Well, a better way to think of this is let's change the form of that. And we're going to go from a fractional exponent to a radical form, and we're going to say it's x to the 1 divided by 2. Okay. Well, we never write the 1, so we don't put it there, and we never write the 2. It's understood to be that. So this would go directly to that. So if you're expecting to see a 1 and a 2 here in an answer, if they're asking you to change it to a radical form, you're not going to see it. Now, let's assume that we had x to the 2/3, and we're changing the form to a radical. Well, we start with a radical, and then of course we have our x to the 2 divided by 3. Notice the divisor is always out here on the outside. Just like in regular division, the divisor is out here on the outside. All right. So now that makes sense to us. 2/3, 2/3, because we see both the 2 and the 3. So any fractional exponent can be translated into its radical form simply by x to the numerator divided by the denominator. Okay, or vice versa. I can go from here to here. X to the 2 divided by 3, 2 divided by 3. All right, I see we've run up on our 10-minute mark, and I don't like to run this over by that much. So we talked a little bit about exponents, what they were, positive exponents, negative exponents, and fractional exponents. And well, that pretty well sums it up. Exponents. All right, have a good day.